3.
Good morning. We're finally starting chapter 30, the last chapter in the book. And there's a lot of words, but over half of them you've already seen. So today we're doing words 1 through 9, and that starts on our favorite page of chapter 30, starts on 774. But the first thing I want to talk about is that picture that you can see here. And you see, this is a time-lapse photography. Here's Polaris. And all these stars are making these circles. Why? Because we're turning on our axis. And that picture's on page 37777 in your book. And it's described on page 778 called circumpolar stars. It says some stars are always visible in the night. So that polar star, the circling stars are called circumpolar stars. The stars of the Little Dipper are circumpolar for most observers in the northern hemisphere and the North Pole. All visible stars are circumpolar. The furthest the observer moves from the North Pole towards the equator, the fewer circular stars that the observer can see. But that picture shows you the maximum one that we see, and I think it's a wonderful picture. So let's start with our first word, just star. You've had that before. Stella, stellae, feminine first star, a large celestial body that's composed of gas that emits light. So every one of these circles are the light emitted on a time-lapse plate as the Earth is turning on its axis. So let's go to word 2, please. You've had Doppler Effect before from Christian Doppler, Austrian mathematician and physicist, and the Latin verb efficio, efficere, effice, effectum, effect, cause. So, an observed change in the frequency of the wave when the source of the observer is moving. Now, we had the Doppler effect before in sound. Remember, you hear a siren coming towards you, and it goes, ooh. As it comes toward you, the pitch goes up. As it passes you, the distance gets longer, the pitch goes down. Well, the same is with the light. The redshift in the spectral lines of the light from distant galaxies or stars caused by their receding motion. And we talked about that before. Can we have the blue shift, please? The blue shift. A shift in the spectral lines of light from distant galaxies or stars caused by their approaching motion. Now remember our little friend Einstein, who made the terrible mistake. He didn't believe in the expanding universe, and he made that terrible mistake. And he had when Hubble showed them the expanding universe, he had him change his whole theory, accepting the Big Bang. So then that's the red shift is moving away from you. The blue shift is when it's coming toward you. The other next word is light year, Old High German light and Jahr year. The distance that light travels in 1 year, about 9.5 trillion kilometers in 1 year. Nobody understands what a trillion kilometer is in your mind, but it's a long distance. I love the next word, parallax. We talked about that earlier in the book. Greek parallaxes, to vary, decline, or para, side by side, and alios, another. So it's the apparent shift in the position of an object when viewed from different locations. A method of determining the distance from the Earth to a star based upon the shift in the apparent position of the star viewed from different angles as we or the star move. Now, I gave you that wonderful experiment. I said, put your thumb up and then block out your mother or somebody, okay, with one eye closed, and block out the head of your mother or father or your brother, and when at that distance that your thumb covers it, then shift eyes without moving your thumb. Then go back and forth. That's parallax. With geometry, you can figure out the distance then to these stars or galaxies. And if you do geometry later, you'll understand what that means. But parallax is that wonderful, wonderful word, and we've had that before. Word 7, Cepheid variable, from Greek Cepheus, the husband of Cassiopeia, I don't know how to pronounce it, father of Andromeda. He was placed among the stars after his death. And then you have vario, varari, varavi, varatum, to vary. A star that brightness and fades at regular patterns caused by the rhythmic swelling and shrinking of the star. Now that's one kind of Cepheid variable. If you could go up word 2 to get word 9, okay. And you have to understand that. But if you have a binary star system, and they're so far away from our point of view, they look at one, but if they're circling each other, all of a sudden they're brighter, then they get dimmer. And then they get brighter as this is going around, brighter and dimmer. That's another way of thinking of a Cepheid variable, but there's probably 2 ways in astronomy that is formed. Now the next 2 words are the most important. Apparent magnitude and absolute magnitude. Wow, what does that mean? Very simple. Apario, aparia, aparui, come into sight. And magnitude, magnitudines, feminine third, greatness and size. The brightness of a star is seen from Earth regardless of the distance from Earth. That's the apparent. How do stars appear to you from Earth? That's just apparent. Because the further away, you're going to look dimmer. But if you could put all stars at the same distance, then you have absolute magnitude. The brightness of the star would have at a fixed distance, and they chose this 32.6 light years from Earth. If you could, in imaginary sequence, put all the stars at that same distance, that would give you the absolute brightness of the star, called absolute magnitude. So we see only the apparent magnitude. Then you have diagrams in your book for these. If you look at page 778, you have the red shift and blue shift. So that's a good diagram. You have the parallax on the next diagram, and you can figure out the distance then. And that's the last word for this section, is on page 780 there, the apparent magnitude and absolute magnitude. And you have that funny diagram on page 780, figure 6. The sun, which has an apparent magnitude of minus 26.8, remember it seems to be backwards, is the brightest object in our sky for us. For us. All other objects appear dimmer in the sky, so they have an apparent magnitude higher, so it's in the plus. So if you look at that diagram, it's just the opposite of what you think it should be. So we're in the minus, and then we compare everything else as dimmer, and it has a plus value. And you say, how come? Well, astronomers did this to us, and you just have to accept it. Okay, we finished the first thing. I want you to do the questions on page 780, and then that's the first segment of chapter 30. So thank you, and that is due, as I said, on the 14th of May. I'm going to do the next series, so you have them all, so if you want to work ahead, and Miss Kelly will put them up all on the 14th. So you'll have all the rest of these segments on the 14th in case you want to work ahead. So I thank you for everything. I hope everybody as well. All the monks have been tested, and we all are surviving. No one has this terrible plague as yet. So thank you and goodbye.